So we did this last time. We started with a function. We had a secant line that we allowed to get closer and closer, the 2 points, until the change in x gets really close to 0. Well, the reason why we can write the slope of the secant line in this manner so this should be a minus f of x1 all over delta x, is we want to introduce here a term of limit. And limit tells us what happens to our function as a variable goes really close to another number. So let's do a quick example of a limit. So we're going to look at a function and to see what happens to that function. So here is f of x equals x squared minus 4 all over x minus 2. So we can rewrite this function. This is equal to x plus 2, x minus 2, all over x minus 2. And what's nice about this is now we can cancel out these terms and we can draw a quick graph of what this function looks like. So here is 2, and it has a slope of 1. So this is f of x is equal to x plus 2. But this is not the function that we originally set. Our original function is x squared minus 4 divided by x minus 2. Well, what happens when x equals 2? So right here, when x equals 2, this function now becomes 2 squared minus 4 divided by 0. This, my friends, is bad. This is what Dr. Brown in Back to the Future was afraid of. If you divide by 0, the time-space continuum is destroyed. And so what that means is right here, when x is 2, this function is actually not defined. There's just a hole there. So to redraw the graph, it would start at 2, it would go forward, it would have a hole, and then continue forward. What limit allows us to do is while this graph is not defined at x equals 2, we want to say as x approaches the number 2. So as x is getting really close to 2, we want to know what happens to f of x. So if we take the limit as x approaches 2 of f of x equals x squared minus 4 over x minus 2, well, this graphs out a lot like x plus 2. And what the limit then says is as x approaches 2, f of x looks a lot like 4. But it can never be 4 because if x equals 2, then Marty McFly dies. Don't let Marty McFly die. So the limit allows us to define that. So the limit of this would just equal 4. We can come to a concrete answer by using limits. And this is what we're going to do when we're going to look at the slope of the secant line. Is we see here that the change in x is getting smaller and smaller, but we actually want the change of x to be 0. But why can the change of x not be 0? And it's because of this denominator. If delta x is equal to 0, Marty McFly dies. We don't want him to die. Therefore, we need to use the idea of the limit to be able to define the slope of a tangent line at a given point. And that's what we're going to do next, is to use the definition of limit to identify the slope of the tangent line.